What's up, guys, and welcome back. If you were absent the other day, here's the notes for the one day that we had that were not snow days. And if you recall, before the break, we looked at reference angles and co-terminal angles and things like that. This whole third quarter is going to involve trig and things to that nature. So to start with, we're going to review Pythagorean theorem, which is a way that we can find a side of a triangle if we know the other two sides. And so if you recall, we're going to use this to learn how to find segment lengths, ordered pairs, and angle measurements. So if this is a right triangle, I have them labeled A, B, and C. It doesn't matter what variables you use, X, Y, Z, whatever, you can use symbols or whatnot, but just standard A, B, and C, because Pythagorean theorem we know is A squared plus B squared equals C squared. I will say, no matter, depending on what you use, make sure that the hypotenuse, which is always opposite of the 90 degrees, that side opposite, that is the thing that is always by itself in Pythagorean theorem. And the other two sides, it does not matter. So let's look at this example where we're trying to find a side called OP. So here we have a terminal side that looks like before the break we would sketch something like this. This is in quadrant 1, obviously. We have a point at 3, 6. And I'm going to draw a reference triangle. So we did that last semester. We would go from the x-axis and draw a line, a perpendicular line from the x-axis to a point somewhere on the terminal side. Here I'm giving you where that point is. So I'm going to do that like this. And now we have a right triangle. And I'm going to, what I want to find is I want to find OP, which is, if O is the center and P is the point, OP would be the hypotenuse of this right triangle. And it may not look to you obviously like I know two sides of this, but look at the point. The point is 3, 6, which tells me from the origin I've gone over 3 units to the right and I've gone up 6. So I know that that x value is 3. I'm going up 6 here, and then from here I can use Pythagorean theorem to find this side, which is the hypotenuse. So without further ado, we're going to square 3 and square 6, and that gives us 45, and then we need to take the square root of that to find OP. Notice I labeled this OP instead of C, which is completely fine. If I take the square root of that, I'm going to type that into my calculator and get approximately 6.71 is my hypotenuse. So the square root of 45 we would call an exact answer, and 6.71 we rounded it. So to get that, we just typed in the square root of 45 into our calculator. We're not going to talk too much about how to simplify square roots, but square root of 45 can be simplified. I wouldn't normally leave that on there. Okay, so now it's your turn to do the same thing. And if you are watching this for the first time and we're not here, I would encourage you to try this on your own first. And do the same thing. Start by drawing a reference triangle, pause the video, and then see if you get what I get. Now in this example, notice our x value is negative, but when we go and we write a reference triangle, the dimensions of anything will never be negative. So when I go and I fill this out, that length is 4 and this length is 3. And so I'm still trying to find, it's 4, not negative 4, because that we don't have negative lengths. If you did it with the negative, it would be okay anyways, because you're going to square that thing and make it positive. But if we're finding OP, that's our hypotenuse once again, we're going to use Pythagorean theorem. 4 squared plus 3 squared gives us 16 plus 9, which is 25. If I take the square root of that, I get 5. So that hypotenuse for that example is just 5. All right, here I am asking to find the x value of the ordered pair. So we're going to go ahead and start by drawing a reference triangle like so. And when I label my triangle, I'm not going to label negative values because the dimensions are always positive. But I do need to make sure I understand I'm trying to find the x value. And the point in the third quadrant, because that's where that is, x is always negative, and so is y. So I'm going to go through and find out what that x value is, just as I normally would using Pythagorean theorem. And then in the end, I need to remember to make that a negative because I am in quadrant 3. So I'm going to go ahead and put my unknown x right there, and then not a negative 5, a 5, and then I'm going to use Pythagorean theorem. I'm given my hypotenuse is 6, and so I'm going to set this up like this, like so. And notice my hypotenuse is by itself, which it should be, opposite of the 90-degree angle. I'm going to subtract 25 from both sides and I get 11. I need to take the square root of 11 and put that into my calculator, and I get approximately 3.32, which I'm making this negative because I'm talking about the x ordered pair in quadrant 3 is negative. So that is how we can go do that. This one I would also encourage you to do by yourself. Take a second, see if you can figure it out. Pause the video. We're going to start by constructing our reference triangle. Here we're in quadrant 4, and y is negative in quadrant 4, and that is what I'm trying to find. So let's fill in the rest of the triangle with what we know. We know the x distance is 7 from the origin, and we know our hypotenuse of this triangle is 10. So using Pythagorean theorem, we got 49 plus y squared equals 100, subtracting 49 from both sides, and we're going to take the square root of 51. This is going to give us a positive number in our calculator, but we need to make sure we make that a negative, and the reason why, once again, is because we're in quadrant 4, and I'm asking for the y value in quadrant 4. So that is going to be approximately negative 7.14. All right, let's look at trig ratios real quick. This is the SOHCAHTOA, and the SO part, the S stands for sine, the C stands for cosine, and the T stands for tangent. These are ways to, this is just a way to help us remember how to write our ratios. So in a triangle, in a right triangle, remember the side opposite of the 90-degree angle is always our hypotenuse. And with respect to the angle that I have in the bottom right of this triangle, the other things like the O and the H that we see in the SO, one of those is the opposite side. So this would be considered the opposite side because it's the opposite side from the angle that I have showing there. The other side that we have on a triangle, these parts, is the adjacent side. And that would be considered this side right here. It shares a leg, the angle split between the hypotenuse and the adjacent side. So the opposite and adjacent are going to be with respect to the angle that you're referencing. The hypotenuse is always going to be across from the 90-degree angle. So when we go and we write our trig ratios, just look at what angle that I have listed there and tell me what opposite and what adjacent that is. So writing our SOHCAHTOA out, the S stands for sine, the O stands for opposite, the H stands for hypotenuse. So our first trig ratio we're going to look at is sine of theta, which is just our variable that represents an angle, equals opposite over hypotenuse. That's the O and H. The co part, the C stands for cosine, the A is our adjacent, and the H is our hypotenuse. So same thing. And then TOA, we have tangent for the T, opposite and adjacent, like this. And eventually we're going to get to the point where we can find sides and angles using these trig ratios, but today we're just going to get kind of practice writing them out. The other situation is I can have a right triangle, but I can be looking at this angle up here at the top. So the hypotenuse does not change. That's always, once again, like I said, across from the 90-degree angle, but the opposite side now is going to be in a different location because the angle's in a different location. The opposite side of the given angle would be down here, and the adjacent side would be right here. So that angle should be between the adjacent and hypotenuse sides. All right, so here we have an example using numbers, and we're going to just practice writing our trig ratios. So for starters, I'm going to start by figuring out what quadrant this is in, and you don't need to take the time to go through and plot that point going over 5 and up 12, just real quick, and determine what quadrant it's in, and just put a point there. So this should be in quadrant 1 because x is positive and so is y. So I'm going to quickly sketch a reference triangle in quadrant 1, and then I'm going to label it with what I know. So I know that the x is 5, the y is 12, and I need to find the hypotenuse because that's part of my trig ratio. Sine and cosine both have that in there, so I'm going to use Pythagorean theorem. And I end up getting 13 here, so I'm going to plug that in. And now I'm going to look at this and I'm going to say, okay, so my SOHCAHTOA, let's do the sine first since that comes first. SOH, so sine of theta is equal to the opposite of the angle that I'm showing there, my reference angle. The opposite side is 12 and the hypotenuse is 13. So sine of theta is equal to 12 over 13. The co part, cosine, is adjacent over hypotenuse. So what is adjacent of that angle that I have? It's the side that's represented by 5. The hypotenuse is still 13. And then tangent is the opposite side, which is 12, over the adjacent side, which is 5. Now, whenever we talk about how to do this, I should be able to give you something like this and three people can do it three different ways, and we should be able to get the same angle. That angle, that theta, is kind of like our unknown angle in this case, and we can figure out what that angle is for these different side lengths. And if you solve this using sine or cosine or tangent, all three of those ways, we should get the same angle because it's talking about one specific angle on this plane. Let's look at this one real quick and figure out what quadrant we're in. I'm going to go to the left 2 since my x is negative, and up 4, that would put me in quadrant 2. So quickly we're going to sketch up here and fill in my triangle with positive numbers because it's dimensions of a triangle. And then I'm going to use Pythagorean theorem to find the hypotenuse side, which should be the square root of 20. Now what I'm about to show here, don't stress out too much about this, but there's something that we do not do in math, which leaves square roots or radicals in the denominator, and we do what's called rationalizing the denominator, which means to just get rid of that thing. So I'm going to show you what that looks like real quick. So with respect to this given angle, when I write my sine, the opposite of this angle is 4, and the hypotenuse is square root of 20. So this next part is I want to get rid of my square root in the denominator because we can have them in the numerator, but we don't ever want them in the denominator. So what's about to show is I want you to understand I'm trying to cancel this square root. So if I'm trying to cancel like a square root of x, I would square it, right? Or a square root of 3, I would square it, which is the same thing as multiplying that thing by itself. So I'm going to multiply the square root of 20 by the square root of 20 in the denominator. But once I do it in the denominator, I also have to do it in the numerator as well, so it doesn't change the value. So I'm going to write something like this. And really, I'm multiplying 4 over square roots of 20 by 1. It just doesn't look that way. It's disguised as square roots of 20 over square roots of 20. But I'm doing this specifically for the purpose of undoing the square root in the denominator. And now I have something like this. And then we do have a fraction that does need to be reduced. 4 over 20. We can divide both 4 and 20 by 4, and we are left with 1 over 5. And this would be our final simplified answer for this problem. Our cosine, we're going to also multiply by square roots of 20 over square roots of 20 to cancel or rationalize the denominator. Then we're going to reduce the fraction to 1 over 10, and we get this. Our tangent in this case is actually fairly simple. We don't even have a radical. Opposite of the angle given is 4, adjacent is 2, so 4 divided by 2 is just 2. And that is all we have for this right triangle trig.